Imagine an ocean deeper than any found on Earth, sealed beneath a layer of ice so thick that sunlight can never reach its depths. Now picture that ocean not on our planet, but orbiting 500 million miles from the Sun, circling the largest planet in the solar system. That's Europa, one of Jupiter's largest moons, a world that, despite its frozen surface, could be hiding the ingredients and environment necessary for life. Europa's icy shell isn't just a barrier, it's a tantalizing mystery. Scientists estimate the ice crust could be anywhere from 15 to 25 kilometers thick, but beneath that lies a vast liquid ocean, possibly 60 to 150 kilometers deep. To put that in perspective, Europa's ocean could contain more than twice the water of all Earth's oceans combined. Why is Europa so interesting to astrobiologists? For life as we know it, 3 main ingredients are necessary: liquid water, energy, and chemistry. Elements and molecules complex enough for biology to work with. Amazingly, Europa seems to have all 3. Let's consider the first: liquid water. Unlike most other frozen bodies in the outer solar system, Europa is thought to hide a liquid sea beneath its solid ice. The heat that makes this possible doesn't come from sunlight, but from tidal flexing. Jupiter's immense gravity stretches and squeezes Europa as it orbits, generating internal friction and warmth. This tidal heating keeps the ocean from freezing solid, even in an environment where average surface temperatures hover around -160 degrees Celsius. But water alone isn't enough. The second critical piece is energy, something that life can use to power metabolism, to fuel chemical reactions necessary for survival. On Earth, the vast majority of life ultimately relies on sunlight. But in the total darkness of Europa's ocean, sunlight is out of the question. Instead, any potential organisms would have to rely on chemical energy. Here, again, Europa gives us hope. Where Jupiter's powerful radiation slams into the ice on the surface, simple molecules like water and carbon dioxide can be split into more reactive substances, like hydrogen peroxide and molecular oxygen. These products might eventually get mixed down through the ice, serving as possible energy sources for any living organisms below. Even more intriguing is what might be happening at the bottom of Europa's ocean. On Earth's sea floors, deep in the absence of sunlight, hydrothermal vents spew hot, mineral-rich water into the cold ocean. Around these vents, thriving colonies of extremophiles, organisms totally independent of sunlight, feed off chemical energy from the planet itself. If Europa's core is still geologically active, it might also host hydrothermal vents, providing essential chemical energy and nutrients to support life. In a way, Europa's hidden ocean is like Earth's own deep-sea environments, with one huge difference: the scale and the complete absence of surface-based input from the sun. And that raises one of the great astrobiological questions. Could life on Europa, if it exists, resemble the hardy, extreme-loving microbes we discover in Earth's own dark oceans? The answer is maybe. With the right mix of water, energy, and chemistry, nature has evolved life in some of the most unlikely places imaginable. Let's pause here for a moment and consider a famous passage from a poem by Emily Dickinson, written in the 19th century, long before humanity imagined the icy moons of other worlds. I dwell in possibility, a fairer house than prose. Reflection. What does it mean to dwell in possibility, especially when we think about worlds like Europa? Scientists don't yet have direct evidence for life beneath the ice, but the very notion that life could exist there, independent of everything we know about sunlight and surface-based ecosystems, expands our understanding of where biology can thrive. Europa isn't just a physical place, but a symbol of all the unknown possibilities in the universe, something that continues to urge explorers forward. Returning to the science, how might organisms actually live in Europa's ocean? Some ideas point to simple microbial life. Single-celled organisms, similar to the archaea and bacteria that flourish in Earth's most inhospitable places. These microbes could feed on chemicals produced either on the surface, delivered by radiation, or generated at hydrothermal vents by chemical reactions deep underground. But could more complex organisms exist there? That's a stretch, but not out of the question. On Earth, entire ecosystems flourish around deep-sea vents, from worms to crabs to strange, eyeless fish. Given enough time and stability, Europa's ocean might have allowed something complex to evolve, although the harsh energy constraints could limit biology to simple forms. Of course, the challenges are huge. Europa's thick layer of ice isn't only a barrier to sunlight, it's also a shield, protecting whatever lies beneath from cosmic radiation, but also making it incredibly difficult for us to find out what's really going on down there. The prospect of drilling through kilometers of ice or sending sophisticated probes capable of sampling ocean water isn't science fiction, but an engineering challenge that humanity has not yet overcome. Still, there are ways we might learn more even without diving directly into the ocean. The surface of Europa is riddled with cracks, ridges, and chaotic terrains, evidence that material from the ocean might occasionally well up and freeze on the surface. By analyzing the composition of these salty, refrozen regions, future missions might get indirect clues about what's happening deep below. And missions are coming. Spacecraft like Europa Clipper and JUICE will soon orbit and study Europa in unprecedented detail. With powerful instruments, they'll analyze the thickness of the ice, the chemistry of the surface, and search for plumes, jets of water vapor that seem to erupt occasionally from the moon's surface. If these plumes exist, they might carry material that originated directly from the ocean, offering humanity's first real sniff of what lies beneath. Consider these lines from the philosopher Lucretius, meditating on the endless variety in nature. Nature is free and uncontrolled by proud masters, and runs the universe by herself without the help of gods. Reflection. Nature, free and uncontrolled, gives us not just the familiar, but the truly unexpected. Life, if it has found a way to persevere under Europa's ice, would be a striking example of nature's creativity, unaided by any guiding force, flourishing wherever the conditions allow. Let's revisit the question, what would we hope to learn if life exists on Europa? Finding a second, independent genesis of life in our own solar system would radically change our understanding of biology and the universe. Until now, all life we know shares a single, ancient ancestry. It's all linked on the same tree of life, on Earth. If something totally separate has emerged on Europa, it would mean life is not a cosmic rarity, but a common outcome wherever conditions allow. Even if organisms on Europa are limited to the simplest forms, that discovery would teach us that biology can take root in places wildly different from home. The more alien the environment, the more thrilling the possibility. This idea appears in a line from Walt Whitman. I am large, I contain multitudes. Reflection. Here, I contain multitudes reminds us that the universe is never simple or singular. Europa may be one moon, but it's part of a much grander story of water, chemistry, and the potential for life wherever we find the right combination. Even the smallest moon in the coldest reaches can contain an astounding diversity within. How would we recognize life if we found it there? We tend to search for things familiar, a cell wall, perhaps, or certain chemicals. But Europa reminds us that life's possibilities might look strange, that the signatures of biology could be different from what we expect. This is where poetry, philosophy, and science touch on a single theme: the deep power of the unknown. Each new scientific mission to Europa is like sending a message in a bottle to the universe. Is anyone out there? Will anything reply, even if it's a single microbe detected in a dark, briny ocean? Europa's allure isn't just about what we might find. It's about how much we still don't know. It's about the drive to imagine, to reach out, to test the limits of possibility. So, could Jupiter's icy moon truly harbor living organisms? The answer is simple and profound. We don't know, yet. What we do know is that Europa has the ingredients, the environment, and the energy to make it possible. It offers a new kind of hope, not because it confirms what we already believe, but because it asks us to look beyond, to imagine a universe that is larger, stranger, and more alive than we ever thought. As we wait for the next spacecraft to carry our curiosity into orbit around Jupiter's icy companion, we dwell, for now, in possibility.